Welcome to the Track Advanced Training Program, where you will learn and perfect the skill of sprinting. This program is created for ages 17 to 18 and will not only involve the physical aspects of sprinting, but also the biomechanical aspects of sprinting. In this video, we will tell you how this program will turn you into an Olympic athlete. First, we will be breaking down 3 phases of movement involving sprinting.
The preparation phase for the sprint involves a setup of starting blocks. These starting blocks are specifically made. The blocks have a 45-degree slant, allowing the body to arrange itself in the same degree. Within preparation, there are 3 stages: ready, set, and the last phase is go, is in the execution phase. In the ready position, an athlete may position their feet on the block with their dominant foot in front, with both legs flexing in the knee. In this stage, the hips are also flexed and the feet are dorsiflexed, and the elbows are extended to the ground. In the set position, the legs are slightly extended. The front leg is now at 90 degrees and the back leg is at 120. According to the outperformed sports, during preparation, the arms should be perpendicular to the track and shoulder width apart. The head and torso should be level and the body is relaxed, is in a position with no muscle tension.
In the execution phase, the front or dominant leg experiences triple extension. This is the extension of the hip, knee, and ankle. The front leg pushes off the block and the back leg pulls the body forward. This allows the runner to create a fast motion or impulse that increases the velocity. A 45-degree angle should be maintained. Changing body angles causes a loss in speed. It's important to stick to one angle and push down the track. 90% of the power comes from the front leg. It provides the optimal position for power creating. The back leg only creates 10% of the power. If you use more of the back leg, it will slow you down. It's also important that the sprinter looks out 4 to 5 meters ahead and slightly leans into the wind, increasing momentum. Their arms should be close to 90 degrees if possible, and their hands and arms should swing in a straight line because they will guide the legs and increase momentum. This particular phase includes the summation of the knee, elbow, and hip joints in order to create maximum velocity, all allowing the athlete to run faster.
In the last phase, the finish line is near. It's important to look at the finish line so your head is at an angle. In doing this, the hip angle is altered, moving them backwards and tucking them underneath the body. This position limits the force applied to the track and speed. Sprinters continue to walk to allow their cardiovascular system and muscles to recover, preventing a strain on the joints or tendons. This is why after a race, you see most athletes walking it off instead of sitting and laying down to catch their breath.
Common tips we tell our runners is to
perfect their block start skills. Block starts allow sprinters to efficiently hit body positions that overcome inertia and achieve the fastest acceleration, in turn allowing them to reach their max velocity. The quicker an athlete can accelerate to their max velocity, the faster they can run.
Another key tip is to keep their arms as close to the body as possible at a 90-degree angle. In doing this, there is no additional drag. Wind is already working as an external force to be overcome, so having your arms away from your side will add to the drag. Keeping arms close to the body will allow for max momentum.
The last tip is to wear compression gear when running. Compression gear is tight, thin clothing that supports muscles and increases blood flow and venous return. Both of these aspects can help increase the ability to perform to the best.
The sprint involves the collection of several fundamental movement patterns. Some include the squat and gait. Fundamental movement patterns like gait and squats are essential for sprinters to maximize speed, power, and efficiency. Gait analysis allows sprinters to refine their stride mechanics and improve ground contact efficiency and minimize energy loss during running. Squats, on the other hand, are crucial for building lower body strength and explosive power, which directly enhances the execution phase and acceleration in a sprint. Proper alignment to muscle activation during both gait and squatting movements also helps reduce the risk of injuries, such as hamstring strains, which are common in sprinting. By mastering these patterns, sprinters can optimize their biomechanics, improve performance, and achieve faster times on the track.
During the program, we direct our athletes with cues that will help them optimize their performance. These reminders can quickly allow them to readjust and correct their form. Some of these cues include:
push the ground away from your front foot. This tells athletes to focus on generating power from their front/dominant leg.
lean into the run and stay low at 45. This tells athletes to adjust their angle to allow for optimal momentum.
Eyes forward, head steady. This tells athletes to adjust their form during execution.
Arms are swung, kept by side and at 90. This tells athletes to readjust the form of their arm. Swinging will create angular momentum. Keeping them by their side reduces drag, and a 90-degree angle is optimal for gaining momentum.
All these cues help remind the athlete to improve their form to allow them to reach optimal performance.
In sprinting, muscles play an important role for generating power, used to pull the body forward and create speed. In the execution phase, muscles are contracting and stretching as the body pushes off the starting block. The main muscles in the legs include the gluteus maximus, bicep femoris, rectus femoris, gastrocnemius, and the soleus. These muscles help generate the power used to push off the starting block during the execution phase. Other muscles like the rectus abdominis and obliques provide core support for energy transfer during the execution phase. And biceps and triceps help create the swinging motion that increases momentum.
In the program, we also teach biomechanical aspects of sprinting. Sprinting involves many principles, but the two most important ones are impulse-momentum relationships and direction of applied force. The impulse-momentum relationship states that the greater the applied impulse, the greater the increase in velocity. In sprinting, the more force applied to the block during the push-off, the greater the velocity and the faster the athlete will run. Though the continuity of the tibiofemoral, the acetobifemoral, the glenohumeral, and the radial/unihumeral joints, the maximum velocity can be produced. For direction of applied force principles, it states that the forward force must be applied backwards. In sprinting, force is applied pushed back into the blocks, allowing for the forward motion. This is illustrated in the picture above. Understanding these principles can allow athletes to fully identify the reasoning behind their movements and form during sprinting.
Now we will be showing a video of our formal client that went through the few weeks of training. In the first video, his form was very off. In the second video, his form improved. And in the third video, he was able to achieve the right sprint.
This is one example of the preparation for starting your sprint. You must place your blocks down. And now she's ready to go.
Now the next phase is execution, and now we have follow through.
These are just some of the examples and aspects you will learn at our sprinting program. We hope you join and have a wonderful day.